What is an ice table? An ice table is a way of organizing information about a chemical equation, about a chemical reaction at equilibrium, to help you see any missing pieces, to help you see the full picture, the big picture of the system. Let me give you an example. Let's say somebody tells me they have a reaction. Hydrogen plus iodide reacts to form hydrogen iodide. And they tell me that in this system, if we start with a half a mole each of hydrogen iodide, I end up with 0.78 moles at equilibrium of hydrogen iodide. They've now given me all the information I need to know all the equilibrium concentrations, know what K is. I can know a lot of things about this system, but it's not clear from the way that information is organized what all that information is. An ice table makes it clear. For example, if I set up a table right under the balanced chemical equation and I show what my initial concentrations are of each of those materials and one change or one equilibrium, for example, the equilibrium concentration of hydrogen iodide being 0.78, I now know everything about that reaction at equilibrium. The ice table lets me see how to connect the different pieces to fill in all the missing information. For example, if I know I started just with a half a mole each of hydrogen and iodine, then that means I didn't start with any hydrogen iodide. That means that for this reaction to occur, I produced 0.78 moles. The change in hydrogen iodide was a gain of 0.78. Well, by stoichiometry, I know that every time I consume one iodide molecule, I produce two hydrogen iodides. That middle column, change, that's the ratio of all those things is indicated by the balanced chemical equation. So if I'm produced 0.78 moles of hydrogen iodide, I consumed half of that, 0.39 moles of iodide. I also consumed 0.39 moles of hydrogen. And I can see that by laying it out in the ice table. Now, if I add that change to my initial concentration of iodide, I see that at equilibrium, I'm going to have 0.11 moles of iodide and 0.11 moles of hydrogen. Now, that means I have now all the information I need to know what K is. I mean, remember, K is, according to the law of mass action, just products raised to their coefficients over reactants raised to their coefficients. That means that I have at the top 0.78 moles of hydrogen iodide. It also means I have 0.11 moles of hydrogen, 0.11 moles of iodide. And if I crunch those numbers, I find that that means K is equal to 50. And all this information is available to me from just a simple information of what concentrations I started with and one change or equilibrium. And I can see it, I can sort it, I can organize it by using an ice table.